When working out the perimeter and area of a circle, you need extra information. First piece of extra information is that the distance around the outside of a circle is normally called the circumference, not perimeter. So I'll refer to it from now on as circumference. The word circumference literally means the distance around the outside, but it also means the line itself. But we're talking about the length of that line being the circumference. So how do you work out the circumference of a circle? Because with a polygon, you would just add up the lengths of the individual edges. You can't do that on a circle. So how do you do it? Well, it requires the use of a special number called pi, which is a Greek letter. That's the symbol for it, and it's spelled P-I, pi. Pi is a constant, it's a fixed number, it's set, and it's just over 3. In fact, it is 3.1415,9, and it goes on and on. But you never need to use it to that much accuracy. If anything, in a test without a calculator, perhaps 3.1. More likely just 3. But if you remember, it's just over 3 rather than just under 3. That can help you. Now, in fact, 3.14159, etc., is very close to 3 1/7. That can be useful. So it's roughly 1/7. So how do we use pi to help us work out circumference and then area of a circle? Well, let me point something out. When you have a circle, how do you give its dimensions? With a polygon, you would give the lengths of these edges. You might give the length and the vertical height or the slant height, but none of that applies to a circle. The way we define a circle is by the distance from the center of the circle to the circumference, which I'll draw a line there. Now that is called a radius. So a circle is defined by the length of the radius, which we normally abbreviate to r. Another measurement relating to a circle that you need to know is the diameter. Now the diameter is simply the distance from one edge to the opposite edge. That would be called a diameter. Now there's the center of the circle, and a diameter must go through the center, otherwise it would not be a diameter. So you will notice that if that's the radius, then this piece here is also a radius, and this piece here is also a radius. So from that reasoning, you can see that the diameter is simply 2 radii, end to end. So in fact, for any circle, the diameter is twice as long as the radius. So if you're given one, you can always work out the other very simply. For the diameter, I'll call it D, capital D. Now the circumference, remember, C, is the distance all the way around the outside. So let's see how to work out the circumference of this circle. Well, the formula is this. The circumference is equal to pi times the diameter, which means that if you take absolutely any circle of any size and you know the diameter, you simply have to multiply it by pi to know how long the circumference is. So if the diameter of this circle were, say, 10 centimeters, the circumference would be just over 30 centimeters. In fact, it would be 31.4159, etc. centimeters if I wanted it more accurately. That can get you a quick mark in a maths test if it's multiple choice, because you know the answer has to be a bit over 30. Now, because the diameter is exactly twice as long as the radius, instead of having d, we could have 2r, meaning 2 radii. And when it's written in terms of the radius, we write it as circumference is 2 pi r, which means pi times 2 radii. But it's written in this order because in algebra, when we have a number as opposed to a symbol or letter, the number must always be written at the front. Hence, circumference is 2 pi r. Let's apply it. Well, let's give this circle a measurement. Let's suppose that the radius of this circle is 7 centimeters. And supposing we wish to work out the circumference of this circle, all we do is substitute. One tip about substitution is first write the formula, then substitute. So for this circle, C equals 2 times pi. Now, you can take pi as 3 or 3 1/7. I'll just put it as 3 to keep the arithmetic simple, times 7. So 2 times pi times the radius. 2 times 3 is 6, 6 times 7, 42. And since the radius is in centimeters, the circumference, which of course is a length or distance, is also in centimeters. If we wanted to do this more accurately, we would have put 3 1/7. In order for you to see how much of a difference it makes if you took pi more accurately, I'll redo it, but taking pi as 3 1/7. So in that case, when I substituted, C would have been 2 times 3 1/7 times 7. So if I did that, 3 1/7 times 7, well, 3 times 7 is 21, and then 1/7 of 7 is another 1. So 3 1/7 lots of 7 is actually 22. And 22 times 2 would be 44 centimeters. So if we took pi as 3 exactly, it would have come out as 42 centimeters. But when we took it as 3 1/7, it comes out as 44 centimeters. So that should give you some help, that if you have a multiple choice question involving the circumference of a circle, you know that the answer you get by taking pi as 3, it needs to be increased just by a small proportion in order to get a more accurate answer. So that is how you work out the circumference of a circle. Now, if we had been given the diameter, clearly the diameter would have been 14 centimeters. And then we could have just said, oh, circumference is pi times diameter. So 3 times 14, 42. It doesn't make any difference because D and 2R are exactly the same for any given circle. So let's go now on to the area of any circle. The formula for the area of any circle is A for area equals pi r squared. So remember, if you're given the diameter of a circle, that's no problem. You halve it to get the radius, and then you substitute into this formula. And then it would look like this. The area of this circle would be pi, we'll just take it as 3 to keep the numbers easy, times r squared, which is 7 squared. Remembering BIDMAS, you have to square the 7 before you multiply by the 3. Indices come before division multiplication. If you do it in the wrong order, you'll get a wrong answer. So that will be 3 times 49. To do 3 times 49, I would suggest you say this is nearly 50. 3 times 50 would have been 150, but it's not quite 50, it's 1 less. So 3 times 1 has to be subtracted from 150, making 147. Now you have to think area, the unit of area. This is an area. It's not just a number. You can't just put centimeters because the radius was in centimeters. Radius is a measure of length. We are working out an area, the amount of surface, not a distance. And if the radius is in centimeters, then the area will be in square centimeters or centimeters squared. So that's all there is to it. So know the formulae. If you're going to use the formulae, first write the formula, substitute into it, evaluate, and then put the correct unit. So that covers circles. Now when it comes to area, it's fine if you had a triangle, half base times height. If you had any parallelogram, base times height or length times width, vertical height. Trapezium, half a plus b times h. But what if you have some shape like this, which we call a compound shape? Well, you have to use a little bit of improvisation. You have to split the picture like this. There's more than one way to do it, but this is one way to do it. You could split it up into separate areas, work out the area of each piece, and then add them all together. Let's put some dimensions and practice doing that on this particular letter. So here we have the letter F. Supposing that the thickness of all the bars is 3 centimeters. Okay, so that indicates the thickness of all the bars. And let's suppose that the length at the top here is 9 centimeters. And that the height is 12 centimeters. And that this gap and this gap, they're all 3 centimeters. Well, just for the exercise of it, let's first work out the perimeter of this. What I would do is start in one convenient place. I would start at the top because it's easy for me to remember when I finished going around. So starting at the top, 9, 12. Now, we have to do a little working out because I haven't written the length of this piece, but you do have enough information to work it out. Because the width at the top is 9 centimeters and the width at the bottom is 3 centimeters, it means that this piece must be 6 centimeters. So although it's not specifically given, it can be worked out. We do need one more measurement, which is the length of the shorter cross piece on the F. We'll call that 3 centimeters as well. So all the information we need to work out the perimeter is now on here. So starting again, 9 and 3, 12, 18, 21, 24, 27, 30, 33, 36, 48. And that would be the perimeter of that, 48 centimeters. However, right now we're more interested in the area. How can you work out the area of this? There's not a formula for it, because every irregular or compound shape is going to be special or unique. So there's not a formula for it. All we do is split it into simple shapes that we do know formula for, such as rectangles. Now, how you split this is up to you, but one easy way is to just draw lines there and there. And by doing that, I've divided it into 1, 2, 3 rectangles. And all I need to do now is work out the area of each one. I can call them A, B, and C. A is 12 by 3 centimeters. (36 centimeters squared). B is 6 by 3. 18 centimeters squared. And C is a square, 3 by 3. So the area of the whole compound shape is A plus B plus C. So it's 36, add 18, add 9. So 36, add 18, 46, 54, 63. And it's centimeters squared. So the principle I've shown you here, you can apply to any shape which lends itself to being split into rectangles or squares. Now, you can get questions which require you to do a little more thinking. You may not even be given a picture or diagram. In that case, what you do is sketch a diagram. So that's a big tip, is if the question is about perimeter or area and you're not already given a diagram, sketch a diagram. Here's a question. I'm not going to write it, but supposing there's a small garden shed which is rectangular and it's 3 meters long by 2 meters wide. And you wish to build paving all the way around the shed, and the paving has to be 1 meter wide. The question is, what area of paving stones do you need? Now, the first thing I personally would do is sketch the situation. I'll draw a diagram of it. So there's a shed, it's 3 meters by 2 meters. So the longer length is 3 meters and the shorter one is 2 meters. What we want is a path all the way around it, and the path is 1 meter wide. So that means we want the path to be 1 meter away on all sides. So it's 1 meter wide surrounding the shed, like this. Now, your drawing doesn't need to be accurate. It only needs to depict the scenario. So how do you work this out? Well, it's similar to this problem. All we're doing is combining areas to get the specific area that we want. The path I'll shade in orange. That's the path. And it's 1 meter wide all the way around the shed. The orange area is the area that we have been asked to work out. You'll find often reading a question, it's understanding what it is you have to work out, which is the trick, and the arithmetic itself is easy. That's very often the case. So in other words, a maths test is a test of your arithmetic and your comprehension. So if you've understood the question correctly, you'll know that our shed is 2 by 3 meters and the path is 1 meter wide all the way around the shed, and you have to work out the area of paving stones required for the path. Well, the way to work this out is to simply recognize, and you can see it now, that we have a larger rectangle, which we don't know the length and the width of, and a smaller rectangle, which is the shed itself. And that the orange area, which is the paving stones, is the difference of the two. So if we could simply know and work out the area of the larger rectangle, we could subtract the area of the shed from it to give us the answer. Well, it's actually quite straightforward, because since the path is 1 meter wide all the way around, it can help just to mark it in. We do know the length and width of the outside of the path, because the shed is 3 meters long, then the path is 1 meter this side and 1 meter that side. So in fact, the outside of the path is 3 plus 1 plus 1, 5 meters. And similarly, with the width of the shed was 2, plus there's 1 meter and 1 meter on this side. So 2 plus 1 plus 1, 4 meters. So the area of the path is simply the larger rectangle, which is 5 by 4, minus the smaller rectangle, which is 3 by 2. So the area of the path is 20 minus 6, or 14. And this time, all the dimensions were in meters, so the area of the path is meters squared, the amount of tiling that we need. Okay, so here sketching the diagram in accordance with the information we were given made it very simple. We just subtracted one rectangle from another, and that gave us the desired area. Here's another question. Supposing you have a rectangular piece of paper, and that this rectangular piece of paper is 28 centimeters by 20 centimeters. And what you have to do is cut out the biggest circle you possibly can from that piece of paper. So we want the circle, and the rest of the paper is going to go to waste. The question is, if you did cut out a circle from this rectangular piece of paper, the biggest circle you can possibly cut out, what is the minimum wastage? I.e., what is the area of paper that you have to waste? Well, again, it sounds complicated, but it isn't that complicated when you sketch the situation. If we sketch it, it looks like this. Here we have a rectangular piece of paper, and it's 20 centimeters by 28 centimeters. We're cutting a square out of it. Sorry, we're cutting a circle out of it. Well, the biggest circle that we can cut out would be one with a 20 centimeter diameter. Let me sketch it. It's not accurate, but you can picture it. That's good enough for the purpose of solving the problem. The diameter of the circle cannot be more than 20 centimeters, because if it were, it would stick off the edge of the page, and we can't do that. So, this piece, and all of this would be wasted. And that's what we've been asked to work out, the wastage. How do we do this? You're probably a step ahead of me. It's easy to work out the area of the sheet of paper, length times width. It's just a rectangle. The orange circle is useful, so that's not wasted. And we can work out the area of that circle using the formula for the area of a circle. Area is pi r squared. So we're going to use this formula. And to keep the arithmetic easy, we'll take pi as 3. So, area of the rectangle, I abbreviate that, is length times width, LW, equals 28 times 20. 28 times 2 is 56, times 10 is 560 centimeters squared. Okay, so that's the larger area. Now we want the area of the circle, which is pi r squared. When we substitute, that's 3, because we want to keep the numbers simple. R squared. Well, since the diameter of the circle is 20, the radius is 10. So it's 10 squared. 10 squared is 100. 100 times 3 is 300. Remembering that actually radius is 3 1/7. So it would actually be more than 300. Now the area that's going to be wasted, or if you like wastage, is going to be the difference between the area of the rectangle and the circle. So it's going to be 560 minus 300, which is going to be 260 centimeters squared. Now I'll repeat. If this was a multiple choice exam, I would be looking for an answer smaller than 260 centimeters squared, because I know that the area of the circle will be more than 300, because pi is more than 3. So in fact, if it was more accurate, this would be 300 and something. subtracted from 560. So this would be less than 260. So I'd be looking for 260 or an answer a bit less than 260. If there were several answers which were a bit less than 260, I'd go back and just take pi to 1 or 2 decimal places until I could easily pick out one correct answer. But the principle I'm demonstrating with this example and this example and this example is that just by knowing the formulae for a few simple shapes, you can combine those shapes to work out the areas of seemingly complicated pictures. Or shapes. It is simply a matter of comprehension.